Okay, so 24, 25 linear inequalities in your notebook. We have 4 examples on the page in front of us, so we're going to go through these 4. All right, we've already looked at inequalities. Inequalities were those symbols less than or equal to, greater than or equal to. That inequality word should already be in your brain.
Yes.
The new thing today is this is linear. That means we're drawing lines. We are not on a number line with inequalities. We are on a coordinate grid, which means we're going to have x's and y's. All right, so open up this flap, example number 1. Okay, so you're going to graph this on a coordinate grid, and then you have to do a type of line. It's either solid or dashed, and shade. You either have to shade above or shade below. Okay, so let's tell you when you're going to use a solid line. Just as before on the number line ones, so think back to when we had x is less than 3. X is less than 3, what kind of dot was on your number line, open or closed? Open. And when did we shade that dot in? If we had what? Yes, if it was equal to, that's when you put the equal, that's when you shaded the dot. Well, same thing on here for types of lines. You're going to have a solid line if this symbol up here is less than or equal or greater than or equal. So if you take the extra ink to put the equal to, then you take the extra ink to make a solid line. All right, when do you have dashed lines? That's like the open ones. That's if it's only less than or only greater than. Okay, what about your shading? You shade above your y-intercept if it's greater than or equal to. You shade below your y-intercept if it's less than or equal to. All right, so now we're just going to use what we know about graphing lines and go ahead and graph our equation. All right, so this one right here, our y-intercept is 5, so we're going to go on our y-axis to 5. 1, 2, 3, 4, 5. Put your dot. Your slope is -2. What does that tell you to do?
Down 2.
Yep, down 2 to the right 1. Takes 2 dots to make a line. I have my 2 dots. But you have to look at what we just talked about. It is strictly less than. So is it going to be a solid line or a dashed line? Dashed. So you want to go like this on your line and make it a dashed line. Okay, and my rule always is put your pencil on your y-intercept. Okay, this is something that students mess up. Pretend like this pink marker is my line that I just dashed in. Okay, pencil goes on your y-intercept. Is this less than or greater than? Jessica, watch. Less than or greater than? Less than. That means my pencil goes on my y-intercept and it's below. What side of the pink line am I on? That side. So all of that represents the solutions of ordered pairs that would work in that equation. Sure. So put your pencil without the pink marker. Put your pencil on your y-intercept. Is your symbol less than or greater than? Less than. This is less than. Less than is below. So just go below. What side of this pink line are you on when you go below? You're on this side. So then all this gets shaded. Okay, good. Now we're going to make it a little tougher. So go to example number 2 over here. So example number 2 has this one. Okay, not too bad. So go to your y-intercept first. So Chris, what number up there is your y-intercept? What number up there is your y-intercept? -7. So go to -7, put a dot. Okay, I need my slope now. Up 2 to the right 3. So 1, 2, 1, 2, 3. All right, you got to pay attention to what type of line you're going to make. This symbol is greater than or equal to. So it's going to be a solid line. Very good. So just shade in a solid line. And now your pencil goes on your y-intercept. So everybody put your pencil where you hit the y-axis. So here's your y-axis. You hit right here. All right, is that greater than or less than?
It's above.
It's above. It's greater than, which means above. So move your pencil above. So which side of that purple line are you on? You're on this side. That means any ordered pair up there will work if you substitute it into the equation. That's the significance of this. Okay, so can you all tell me one ordered pair that would work in our example? Anybody want to tell me one ordered pair?
0, 0.
Yes, I would pick the origin too. It's right here. Is 0, 0 in your shaded region? Yes. So what that means is when I sub in 0, 0, let's just do that real quick because this one's pretty easy. When you sub in 0 for x and 0 for y, you should get a true statement. So try it out. What are you putting in for the y? 0. And you need that to be true. I'm going to write it, but remember that's our question mark. We want to make sure that is true. Okay, the next thing you're writing is 2/3. What's going in for x?
What are we doing?
Yes, because you're going to have to sub one in Math Excel. 2/3, what's going in for x? 0, and then you have -7, right? Okay, so let's make sure this is true. What's 2/3 times 0? 0. So good, Darren, I'm glad you picked out 0 because then we don't get rid of the fraction, right? So now I have 0 is greater than or equal to 0 minus 7. What's 0 minus 7? -7. Is 0 greater than or equal to -7? Is that true or false? True. So did 0, 0 work? Yes, and we were just checking our work. So that's one way you can check your work. Yes?
What's the difference between a dashed and dot?
The difference, okay.
A solid and dashed line.
The difference between a solid and a dashed line is the ordered pairs that lie on the solid line will work in this equation as well. However, the ordered pairs that lie on the dashed line, what do you think is going to happen when you try to sub them in? It's not a true statement. Okay? So solid line, like all of these are solutions and anything on the solid line. In this example, any of this is a solution, but not on the line. Good question. That's the difference between solid and dashed. All right, let's try number 3. What's different about 3? Ooh, it's our friend standard form from yesterday, right? Okay, so you can try cover-up method. We talked about it yesterday. If you cover this up, don't you get 4x equals 9? Does that work? What do y'all think? If you have 4x equals 9, does that give you a nice integer? When you divide by 9, 9 divided by 4? No. So solve for y here. That's what I would do with all inequalities anyway, because then they're in the form that's easy just to graph from for these. So we want to solve for y. So what would you do first? Solve, no, I want it in the form, I should specify. I want it in the form slope-intercept form. So minus 4x from both sides. Okay, so now I have 3y is, do I flip this inequality symbol? What do y'all think? No, when do you flip it? If you multiply or divide by a negative. All I did was minus. So less than or equal to negative 4x plus 9. Okay, now what do you do next? Divide by 3. Is 3 positive or negative? Positive, so no flipping signs. All right, divide by 3 everywhere. Okay, cancel, cancel. Y is less than or equal to, stay very picky with your work, negative 4/3. Does that simplify?
No.
Nope, so leave it be. Negative 4/3 x. How about 9/3? 3. Negative 4x plus 3. Good job. Okay, you should know enough now to graph that. So we go to 3 on our y. 1, 2, 3. Slope is, yep, down 4 to the right 3. Okay, pay attention. Is it dotted or solid? Okay, how do we know solid, Olivia?
If it's a solid line, if it's
equal to. If you take that string for the equal to, take that string to make it solid. Good job. Okay, pencil goes on your y-intercept. If it says y is less than, are you shading up or shading down? Down. So that means all of this is represented in the solutions. Okay? All right, good. Last one. Okay, number 4. This one I would suggest on all the inequalities that you get them into slope-intercept form, because then you can go straight from the graph, or straight from the inequality to the graph, instead of checking points. It's faster. All right, so if you got to get this in slope-intercept form, what should you do? Yeah, add 3x, add 3x. So negative 2y is less than 3x plus 10. Okay, divide everything by what? Negative 2. If I divide by a negative, what happens? Yep, flip the sign. If you don't flip the sign, you'll get the wrong answer. So y is, instead of less than, it's going to be greater than. Does 3 divided by negative 2 simplify? The only thing I would do is move the negative where? Up. So it's going to be negative 3 halves x. And how about 10 divided by negative 2? Negative 5. Okay, there we go. So, negative 5. 1, 2, 3, 4, 5. Negative 3 halves. Down 3 to the right 2. Dotted. And what about your shade? Pencil goes on your y-intercept. Shade up or shade down? Up, above. That's that side of that line. All right, cool. How you guys doing?
That's simple.
Pretty good? Okay. I'm going to turn that off.